Let us do question number 2a. We are required to get dy over dx of the function given, and the one I'm enclosing, the function that we are supposed to get dy over dx is 1 over 2 minus x, or rather the function is y is equal to 1 over 2 minus x. Dy over dx of a function, it is expression of the gradient at any one point on the curve. Dy over dx, we get it by f of x plus a small change in x. You subtract f of x, then you divide by the small change in x. But f of x plus a small change in x is equal to 1 over 2 minus now x that has got a small change, that is x plus a small change in x. That is that. Therefore now dy over dx is equal to f of x plus a small change in x, that is 1 over 2 minus x plus dx minus the f of x, which is 1 over 2 minus x, all that divided by a small change in x. Two fractions at the numerator, so we have 1 over 2 minus x minus dx, that is I have computed or rather reduced that fraction there. Subtract 1 over 2 minus x. So when we compute this, we get the numerator is 1, and the LCM for the denominator here is 2 minus x minus dx multiplied by 2 minus x. When we compute that here, this figure, you divide the denominator, you divide by 2 minus x minus dx, you get 2 minus x. Subtract now this denominator here, divide by 2 minus x, you get 2 minus x minus dx is now 2 minus x minus 2 minus x, all other plus x minus or other d plus dx over 2, that is 2 multiplied by 2, you get 4. Here you get 4. Here you get 4. Then 2 times negative x, you get negative 2x. Then x times 2, you get minus 2x. Then negative x times negative x, you get x squared. Then negative dx times 2, you get minus 2 dx, and negative dx you get plus x dx. So that fraction now, 2 will subtract 2, x, we will subtract x, and therefore the result is dx over 4 minus 4x, that is negative 2x minus 2x, you get negative 4x, then plus x squared, then we have negative dx plus x dx minus 2 dx plus dx, all other plus x dx, that is x, all other dx over x squared minus 4x plus 4 minus 2 dx plus x dx. We have now reduced the top, that is the two fractions. We have simplified them, and they have reduced to all that fraction. That is, this is the fraction. It has the two fractions have reduced to 2. Now finally, what we have is dy over dx should now be equal to x dx over x squared minus 4x plus 4 minus 2 dx plus x dx, all that fraction over dx. Now when we divide the top fraction, you divide by the dx will cancel out, and now what we have finally is 1 over x squared minus 4x plus 4 minus 2 dx plus x dx. We have saying is repeated here that we have this one will cancel out, because when you are dividing they will cancel out, and now what we have is 1 over x squared minus 4x plus 4 minus 2 dx plus x dx. That is dy over dx is equal to that. Now when the dx is so small that it is approaching 0, when dx or the change in x is so small that it is approaching 0, then we expect that negative 2 dx also to approach 0, and x dx will also approach 0. So when the two values approach 0, now the whole problem, or the whole computation reduces to, okay, dy over dx now reduces to 1 over x squared minus 4x plus 4. And that is the way we get dy over dx of a function from the first principles. That is the answer.